Hey everybody, my name is Andrew Nagy, and I'm with Celona. We are a CBRS and private LTE manufacturer of infrastructure solutions, and today I want to introduce you to the Celona Network Planner. This week we've had a deep dive session, and some of you have been in there, and we've been training some folks on CBRS and private LTE for enterprise use, which, just for a 30-second intro to what that is CBRS is new spectrum in the 3.5 gigahertz range that the FCC has opened up. It's a hybrid between licensed and unlicensed spectrum, so it's a shared spectrum paradigm with like tiered licensing as well as general access. And so this is going to be deployed by enterprises both for indoor and outdoor use cases, for use cases that, maybe they have wired solutions today or mission critical applications that, they just haven't been able to move over to Wi-Fi today. So think of it as another complementary technology in addition to Wi-Fi that you can deploy for your customers out there to solve, business problems that they have. So more options is never a bad thing. Along those lines, though, what I want to share with you today is the network planner that we have. So that's a starting point for you to understand what the requirements might be to design and deploy a CBRS private LTE network for those customers. So the starting point is really driven very similarly like it is in Wi-Fi today. We look at wireless coverage and capacity planning and some of the key critical parameters for a private LTE network. In addition to the ones that you may be familiar with, like facility type and coverage area that you need to plan for, as well as then device count and density and application requirements as far as capacity goes, you also need to understand facility geolocation, because the spectrum is licensed and it has to protect incumbent users for primarily Navy radar on aircraft carriers coming along the coasts. So there's a dynamic check-in process with a spectrum access system to grant you access to spectrum dynamically, and then once you have a grant, you can use those frequencies for operation. So when you're planning and designing a CBRS network, you need to know where that network is going to be deployed, and you have to look up with these SaaS vendors what spectrum is available in that specific location for you to use. So part of the design process is understanding where you're at and what spectrum is available. The Celona Network Planner has a couple of key features. One, it does tie into that geographic location, so you can design for the specific GPS coordinates of radios that you're going to be installing. You can do coverage assessments based on square footage or drawing outdoor areas on maps dynamically. And it has an API, so you can automate this process for a large number of sites as well. So if you have tens or hundreds or even thousands of sites that you need to plan for, you don't need to do this manually. You can script it through DevOps and go in and hit our API and get an understanding of what spectrum is available in all of those locations, as well as then based on your requirements, potentially how many radios you need. It does integrate with those SaaS vendors, so those are back-end database vendors that maintain the spectrum and the mapping of what radios are deployed where and what spectrum is available for you to use. So we integrate in real time with the network planner into those SaaS vendors' databases. So we do a real-time spectrum inquiry lookup on what spectrum is available for those facilities. We also have what-if analysis and interference modeling. So today you might have the full 150 megahertz of the CBRS band available, but after, let's say, the priority access licenses are sold coming up in June of this year, and they start getting deployed, they will take priority over a subset of that spectrum. So you might want to do some analysis modeling of what happens if those PAL license holders come into that location or near me, and they start taking some of that spectrum out of the band. What does that look like, and how does that influence my network design, so you don't have to go back and redesign it later? So some people may take a more conservative approach to designs of their network. And then we also have very sophisticated modeling on the back end that uses discrete event network simulation and regression modeling. That's kind of a mouthful, but essentially what it is we use a lot of regression modeling taken from actual environments of various types. So various facility types like warehouses we have, and industrial sites, generic office sites, suburban or campus locations. We've aggregated a large number of data on what those, what the RF in those areas look like, what the propagation looks like, and what the attenuation characteristics look like. And then we do a lot of modeling around RF link and what the LTE clients will experience for receive power, signal to interference and noise ratio, and then what essentially performance they can achieve given the coverage area that you're trying to plan for and the capacity requirements. So it is available on the web for free. All you have to do is put in your email address. So if you're looking at any customers that are looking to evaluate CBRS or private LTE networks, this might be a good starting point for you to just go out there, start modeling up what it might look like, get a rough order of magnitude of how many radios and what that infrastructure might look like. It's available at planner.celona.io, and I'm going to actually demo it for you now. So first thing is you open the web page. You'll get a screen initially where you have to put in your email address. Don't worry, we won't spam you or anything. We just want to know who's using the tool. So then the starting point is really to put in an address. So I've got a couple of addresses that I've already pre-selected in my planning. So I'm going to do two examples. I'm going to do an indoor environment example, and I'm going to do an outdoor one. So the first one is an indoor one. I'm going to use a warehouse environment. And for an indoor location, maybe I'll just put in a square footage estimate for that indoor location. The first thing that you'll notice is it's checking for spectrum availability over here on the right-hand side. And you see at this very specific location in Texas, all 150 megahertz is available in the CBRS band. So there are no priority access license holders yet, and there is no incumbent that is in that area currently. After I've done that, I've selected a facility type of warehouse. This selects that network regression modeling and the characteristics that we apply to the model based on typical warehouse environments. And we'll go ahead and start putting in some square footage for a coverage-based design. So I'm going to put in 500,000 square feet. And what you'll see here is now on the right-hand side, we've populated an initial estimate for a coverage-based design that you need approximately 22 indoor E-node Bs, which are access point equivalent in cellular parlance. So to cover all 500,000 square feet, you might need 22 LTE APs. That's just for coverage, though. So now what happens if I have capacity requirements that I need to integrate? So let's say I have 1,000 devices, and they require a certain amount of bandwidth uplink and downlink. So I'm going to say 5 meg down and 1 meg up. And so now you see I've gone from 22 to 33 actual radios that I require in order to meet that capacity requirement. So there's a lot of sophisticated modeling on the back end, so it's not just a simple math problem that we're doing on the back end. There's a lot of actual topology and attenuation characteristics that are taken into account. And we can also do the what-if analysis to say, well, what happens if a priority access license holder does come in? I can start unchecking portions of the spectrum, and by default there are 10 megahertz channels in the CBRS band. So let's say I have, at worst case, all of my priority access license holders come in and consume 70 megahertz worth of spectrum. That is the most that a priority access license holders can take in the band. So worst case, you would still be left with 80 megahertz in the band. So you can see with 80 megahertz, I've gone from 33 APs to serve that capacity requirement to 38. So what we've done in there is we started introducing frequency reuse and interference modeling as well. So we can understand how much interference is being calculated between those radios. And if I have less spectrum, I need to reuse those channels more often, similar to Wi-Fi, although the mechanics underneath are a little different. And then we can get an updated count of how many radios I still need. So that's the functionality. Let me show you now one quick outdoor example. So I'll just refresh this, and I'll put in a different example. Again, in Texas. I like Texas. Any Texas people here? Tawny does speak for all of us. Okay, so this location has all 150 megahertz available again. This time I'm going to pick a shipping port or an outdoor location, and instead of putting in square footage, I'm going to draw it on a map. So I'll look at my little Google map here, and I'll see I've got a rail yard right around there. And I'll just circle an area on the map that I want to plan for coverage for. Maybe they're doing something with their trains and they need coverage around the rail area for shipping port container type stuff to offload containers. So you can see there I've selected about almost close to 4.5 million square feet. Now we've switched to outdoor radios. So you see the outdoor radio type selected on the right hand side because this facility type is an outdoor facility, and I need 13 of them to cover that area. So outdoor allows much higher power and can cover much larger, greater range. The capacity planning is exactly the same for the outdoor environment, so I would appreciate it if everybody would go out there and check out the Celona Network Planner if you're looking at what network requirements and how many radios you might need for a private LTE deployment. So thank you.